Welcome to the Value Engineering Experts for another weekly broadcast. I have a very interesting guest, a good friend, Troy Issigonis. And Troy is the Vancouver manager. Hey, Troy.
Hi. Sorry.
You're
Hello.
looking good.
Thank you.
Hey, we both have a similar beard now.
Yeah.
Anyway, thanks for making it, Troy. So Troy and I go way back, reasonably far back, not as far back as Matt Janes and I did, but Troy knows Matt Janes, and Troy runs a very interesting group in Vancouver that's done well. Terrane Group, Terrane. So Troy, I would assume that you're would you be what you'd call a geotechnical engineer, a civil engineer?
Yeah. I started as a technician, actually. Back in the day, I wanted to be a fireman, and long story short, I thought it would help become a fireman if I had some type of education to show that I could get through a post-secondary program. So I took I was at a friend's place who was doing homework. He was in civil structural technology at BCIT, and he had this assignment where he had to measure a site and dig down 10 feet, calculate the volumes, yada yada. And I was like, geez, I think I could do that. And so when I thought about trying to get some type of education or some type of program anyway, so I took it just for that, just because I thought I could get through and it would be something. So I did that, and then I got a job with a firm that really kind of inspired me. I found it really interesting. The big thing is that I could come in 15 minutes late and leave 15 minutes late. So it's all good. Like this concept of, I grew up in a small town where as youngsters, it was a mill town. There was 14 sawmills, there was a mine, and everybody worked. And there the horn goes. If you're not on the green chain at 8 o'clock, the wood starts piling up and you're in trouble, right? So the idea of when I got with these guys with the interview, the guy was late for the interview. He says, oh, he usually starts around 9:30, 9:15, somewhere in there. I was like, what? So anyways, I really drew me to it. The flexibility of it drew me to it. And then I got really interested. My mentors were just spectacular. And I was there for a few years and pretty quickly decided to go back to school and get a degree in engineering. And my degree is civil engineering. And then so that's how it started. Most of us, well, actually, it's about split between civil engineering degrees, the geotechnical engineer have, and or geological engineering. The geotechnical attracts both backgrounds, so to speak.
How old are you today, Troy? You're going to give that away now. How old are you?
Yeah, I'm 64, late 64. So what is that? 58 I'm going to be this year.
Yeah. Okay. So I still got a few years on you. I'm 62. The first time we met, Troy, I think you'll remember, was at Brantford.
Yeah.
In 2001, when I started AC Macon, I started with a pretty tough assignment, which was a job that Isherwood was working on.
Yeah.
And I think Natter was nervous about it. And Natter, being the due diligent engineer, one of the better engineers, as we both know, really set the bar by being the owner of Isherwood. What did you think? Did you think I was crazy? Because you were used to doing shotcrete next to buildings, and that was if you remember, it was almost a cohesionless sand, but it would stand enough.
Yeah.
And we ended up doing you and I innovated a few things. Remember, we did 8-inch verticals. We ended up doing a paper, Natter and I, and it was unheard of that we controlled the movement as good or better than a caisson wall, which was the standard. And we only had 4 millimeters of movement, but I put lots of anchors in it.
I was gonna say, I remember I kind of felt your pain, Martin. I knew that you were putting a lot of anchors in. It was, when you talk cohesionless silt, it was loose. Well, not, yeah,
it was sand. It was basically sand, right?
Yeah, it was sand. Yeah, you're right. Trace silt, no gravel, uniform size. Yeah, it was it's a bad actor, so to speak. How in hindsight, to get the movements that low is Well, it says a lot about how.
Well, I was on the site a lot, and I had a lot of experience. I was doing soil milling before that with National Shoring, Ken Dexterous with
Ken
Matthews.
Dexter, yeah.
Yeah. So, you know, I saw it, and I had that shoring background before, you know, I even met Dexterous at Matthews. And, but I put a lot of verticals in because of that sand condition. And then we made it, I think, extra thick, like it was 6 inches thick. And we had some good people there. Mike Doucette and Rob Black came. And that's when Matcon shipped me an air track. And from one air track and 750 compressor, which was basically looked beat up by the time I got it, Ian Turner shipped it to me. Remember Ian Turner? Yep. Anyway, and that's how it started. And like I literally built HC Matcon from that one job. We actually made money on the job. It was a tough GC. People who are listening in Toronto will remember Bonfield. Bonfield did hospitals, and they were a tough GC. And but they were, you know, they saved time because, you know, shotcrete can save time over caisson walls, and it would have been difficult in caisson walls because you know, what do? You might lose more ground drilling a big hole, right?
Yep. Yeah.
So it was the right system, and Natter was the right engineer. And so the stars aligned, and we got that performance and did that famous paper, Brantford Hospital, Natter and I. So, but anyway, you came out and we hit it off right away. So tell me a little bit about your goals in Terrane Group. You said you're up to maybe 20 people now?
No, we're more than 10, but not 20. It you know, in today's day and age, we've got a couple of guys on contract. To count admin, like we're 12, 14 people, counting if you want to count admin or contract people.
So now you got Paul Davies joined you?
Yeah, so that was when I very much didn't want to be on my own and to have my people, you know, all the young engineers. And in geotech, I think it applies. I guess everybody thinks it applies to them, but mentoring is really important in consulting engineering. And I was really important to me that my staff, the people I worked with, got influenced by more than just me. That there are other senior guys around that they could watch work and they could talk to about geotechnical engineering, and really realize that you really have to grow into being your own engineer. So I when we started, reached out to a couple of senior guys who were also they had sole proprietorships, and said, hey guys, you know, why don't we work together? We could bounce stuff off each other. And so anyways, I got joined with two guys right away that were on their own, Greg Ben Hughes and Jeff Dyer. And both of the guys have like 30 years experience consulting geotechnical engineering. They're career guys that didn't like stumble across it because they're out of work sometime. They you know, went to school to become geotechnical engineers. And then you know, one thing leads to another, and I've known Paul for a long time. Paul and I worked together at a company called McLeod Geotechnical in West Vancouver. And Graham McLeod, who, God bless him, just passed away a year or two ago, he was a South African mining engineer, and he had this medium-sized consultancy. I think that they were about 5 people I think there was 5 or 6 engineers when I got there, and then they started to grow. And then I think there were like 20 people or so when I left, but Paul and I worked together there, and they were a lot like what we would like to be, is a small geotechnical consultancy that is really focused on the engineering, and everything else takes second place to that. And engineering, when I say engineering, it's about presenting a good product, that your English is right, your presentation right, that you communicate it properly. It's not just the calculations, right? The calculations are a small part of what we do.
Yeah, I know that the word I would say is, you know, geotechnical engineering is an art, right?
Yeah.
I mean, you're painting your own picture, and your ability to paint that picture properly I regard you as an expert, and you often refer to site characterization. And so, for the benefit of our listeners, how would you describe proper site characterization? Because I'm sure that's a topic that you have many customers that know you can do that well.
By the way, the thing about it being art, I'm not sure. I don't 100% agree with that. I think a lot of people call it an art when I mean, there's protocols for what we do, and there's way we're supposed to do things. And you know, there's soil. There's a good example is the soil classification systems. There's a few different soil classification systems. Most companies use the unified soil classification system. This is just an example, but it has terms that have very distinct meanings. And like you describe, you know how you describe fine grained cohesive materials with a certain set of adjectives, and you describe coarse grained sands, gravels with a different set of adjectives. And so it's important that you do these things properly. That isn't an art on how you describe like that. I find a lot of people are a little sloppy in terms of how they go about describing materials, how they go about characterizing sites, and they just say, "Oh, well, you know, it's an art, and it's okay for me to, you know, use whatever adjectives I want because you know it's an art. It's like each person is their own. There isn't really as much of an art. The way I see it, it isn't as much as an art as people like to pretend it is or allude to it being. It's very much like in my mind so we'll move into your question about site characterization. So you have a project, and you have to determine the engineering properties of the materials to suit your project. So each site investigation technically should be a little different with respect to what you're building, right? And then site characterization is getting the engineering properties of the soils or the subsurface conditions, really your soil and your groundwater condition, and have those have the site known enough that your engineer can determine engineering properties. That's really it in a nutshell. If you go out and say that, you know, it's sand over gravel, but you don't provide the adjectives and you don't provide the data and you don't provide the information that the designer needs to be able to sit down, pick out what, you know, what unit weight to use, what cohesion value to use, what phi angles to use, what engineering properties, then yeah, you're a little light on what you've done in terms of characterizing the site.
Yeah, those are excellent points. I can always learn the better terminology for sure. But you know me, I'm a contractor, right?
Yeah,
And,
yeah.
But I've worked with a lot of engineers, and you know, when Natter said I want to use Troy, that says a lot, right? When he brought you out, I think he just wanted a Vancouver expert, because in your market you have a tremendous amount of shotcrete, and for the benefit of the viewers that are from Ontario, I mean, you have hundreds of guys doing shotcrete every day in that city. And so would you say that if we go type 1, type 2, and type 3 soil, is that fair to talk a little bit about that? Because generally I would never try to do shotcrete typically in type 1 soils. Perhaps you could, there's a wide variety of type 2 soils, but they can literally shore anything almost with soil nailing. And the Vancouver technique, for the benefit of what makes Vancouver unique, and you probably can date this to the people who started this, but they put the anchors far enough back that it actually has traditional slope stability, right? Versus in Seattle, they truly put the pins in, and all the anchors are the same length, correct?
I've heard it called a lot of different things what we do here, but the one I like is called tied back shotcrete and anchors. So the anchors are designed like tiebacks are designed. They're back far enough that they're outside the active wedge, and whereas the guys down in Seattle, and they really nail systems where they're all the same length, they're all fully grouted or mostly grouted, and they rely on frictional resistance along the grout column. But the thing about that system is that it's a passive system that the soil really has to move to develop that friction. Like maybe it doesn't move very much, but in order for there to be frictional resistance there has to be something moving. Whereas when we stress our anchors, they're designed like a tie back so that the grouted length is well back from your active area, and then you can apply a force on the face of your shotcrete that acts to hold it in place. Fundamentally quite different than the nail system that they do in other places.
Very good. Now you haven't had quite the time to study the new system I came up with, which is I want to replace secants with what we call bypass shotcrete, 2 5-inch layers of waterproof shotcrete. And our testing is proving that we do have zero crack shotcrete perfected. So that system puts drain board between 2 piles, and then you drain that soil so that we don't have leaky tiebacks, and that we're actually proposing to replace the waterproofing on permanent underground structures because of the nature of the shotcrete, really. So I think that there's a tremendous cost saving for developers. And from what I understand with Matthew, he loves it because he's looked at it, and instead of vertical construction joints between every secant pile, we eliminate the construction joints, and we can literally entomb 100,000 square feet with 2 5-inch layers, shifted quilts, drain board behind. And of course, what we find, Troy, is we don't need to design for water table. So the anchors are less. We don't need more anchors, right? We use tied back anchors with a special connection. So when you have time, we'll hopefully get you guys involved in some jobs. And, I certainly would trust you to watch the risk out there and do what we're proposing is full-time QA on the shotcrete. So that would be kind of critical when you're I plan on giving a 15-year waterproof warranty, just like bentonite, because I want to change the industry. And it basically results in huge savings. But, we did a 2-acre bathtub, and you might be familiar because I know Vancouver's doing some bathtubs, and it doesn't apply to every site, certainly not down where the sheet piling goes. But that 2-acre bathtub saves $8 million to schedule, and 58,000. That example we ran was 58,000 tons of CO2. So my thing is value engineering, lower CO2. And I think you might know that much about me, that I got sort of waylaid with a climate change concern. There'd be lots of people in Vancouver that might buy into this, right? In terms of, as long as the soil's right. Like I don't propose to put it in a type 1 soil, right? That's probably sheet piling, or you can drive that Luffer casing. You can imagine in some situations in Toronto anyway, we could put the piles in, let's say 18 at 55s instead of 24 at 60s. 2162s, and the anchors run EBOs, like R51s is what I'm basically looking at mostly, and less welding, and that's where all the savings come. But that's my pitch. Now let's talk about like Shane O'Neill, famous engineers. We both talk about Shane quite a bit. Now Shane is the hydrogeologist, and he's an associate partner like you are of our group. We still have your picture on the website, and we kid around each other. Troy always promises to call me every month, but then every couple of months goes by and I call him. But Shane is great, eh? I understand he might even join you guys.
Well, that would be spectacular. No, he's it's kind of it's funny. Yeah, no, he's a spectacular guy. I was going to tell a story about how we met and
go ahead.
Or even so, after a few years of working after I went back to university, it's pretty. All my mentors had master's degrees, and I was thinking about getting a master's. And as part of that master's, once I had gotten all the mandatory courses done, I took an entire year of groundwater with this professor by the name of Dr. Roger Becky. And at that time, he was a young guy, like 20, maybe 30 years old. 32, starting a young family in Vancouver. Went to MIT or like one of these Ivy League schools on the Northeast, and he was by far the best professor I've ever had. Like, he was unbelievable. And by the way, he since has gone on to become the department head, engineering, I think Earth Science department head out at UBC. But he was really good. And so whenever I would have groundwater design issues, I would call Roger, say, hey, Roger, he would always put me on his wife, who's also a PhD groundwater person, and she consults to the big guys. He's a university professor. He doesn't have time to, so I called with this groundwater problem, and he said, oh, I've got this student, you'll really like him, and he should be able to help you. And he put me on to Sean. And so Sean's over here, he's doing a PhD out at UBC. And so that was how I met Sean. And I can tell you, I've been doing this a long time, and there's not very many good groundwater guys. You just don't come across them very often. Actually, I called him about your project, and it was one of your projects in Toronto. You'd send me the logs, and you were thinking, Troy, I don't think we're going to get any water out of this. And the building's concerned about water. So anyways, when I sat down with Shane and talked to him about it, within about 10 to 30 seconds, he had the till nailed down. He could describe how tight it was. He could describe that there was no water. He was telling me all the same things about water in these tills that you were telling me, like, without knowing it. You know what I mean? Like, using all the same low permeability, low flow rate language. And so it's obvious to me, he got to the hub of the problem within, in real short order. And like I said, there's just not very many groundwater guys, good ones around. And so when I met him and realized how good he was, I've really worked hard to try and maintain a good and positive relationship with them, because in our business, it's all relationships, and to be able to call a guy like Shane and have him answer it's a real asset.
Well, he did 20 plus years in Ireland, right?
Yeah. He had a consultancy, like me, like this is, except all they did was groundwater on large mine sites all over the world. And I don't know, I've never really got the story on why he would want to leave Ireland, leave where he grew up, and move over here to the West Coast even. And yeah,
I'm not sure. I probably talked to him about it, but I've had him on a few things, and he'll charge. He's fair. Like in Toronto, we're going to bring him in for sure to work for these developers, and he has no problem putting a stamp on something. What we're finding is we see the big engineers that, quite frankly, if there's perched water, they'll say this is a serious water problem. In Toronto's perched water, I mean, you have a situation, we drilled in the 80s and did lagging most everywhere, except for caisson walls next to the buildings. And then all of a sudden, they put this bathtub law in, and they end up saying, well, we don't want to expand Ashbridge's treatment plant anymore. But I'm looking at that, and I've been working on it. So I solved this bathtub problem. I have a patent for that. And I took it to the extent of replacing sea cans. We still put the 5 MPa in. There's a lot of sites where you could put a liner in and hit the clay in 30 feet. You don't even need to drive the sea can right to the bottom, let alone interlock it and do all these 1 meter holes. Anyway, it's a tremendous savings, and developers are starting to figure it out. I do as much marketing as I can on it, and I'm pretty busy trying to pick out 2 master licensees. And I'm looking at that in Vancouver too. We're looking at Southwest, maybe Hall Civil, although they're not big in drill rigs, and maybe Norland or somebody like that. We'll have to talk about that sometime. So you have 3 kids, I understand. Any of them engineers?
The oldest one, he's very much not much of an academic, and he's working. He's a tradesman. He's an elevator mechanic. My middle one wants to be an actor. Well, he is an actor. He's doing well, and my youngest one's in university, and the youngest one is the one that had a stroke, and he wants to work for help other people like him that have had strokes or traumatic brain injuries, and help other people get through it. So he's at UVic taking a sociology degree, and I think he'll go to work uh, as in the brain injury program when he's done there. He's hoping to, anyways.
Well, that's great. I'm sure maybe that's probably a charity that you'll help with, right?
Try to, the brain injury program in BC is I think it's run through the Children's Hospital, and it's a pretty large, successful, well-recognized. They do good work. They do really good work. Of course, we help, like everybody in the province, we help out at Children's Hospital. My wife, she's got this gig. She volunteers with the premature out at Children's, and her job is to cuddle babies. That's what she does. Yeah, I guess
That's a great
it's
job.
a tough gig to get. Not very many people do it. There's training involved in cuddling these premature babies, but when they're premature, they're in a basket a lot. They don't get to cuddle with their mom as much. And so they have these volunteers come in and cuddle babies, and she loves it. She did, of course, during COVID, it wasn't something that she did, but she would be driving out there. I forget. I don't know if it was twice. It was, I want to say it was about twice a month, pretty regular, maybe even weekly, that she would drive out to Children's Hospital on a Thursday and cuddle babies for 2 or 3 hours.
Well, that sounds like a cool job. So she's a nurse?
No,
Or
no.
she's just, what do they call that? They say a lot of kids, when they get adopted, that they miss something there, right? And that
Yeah.
it's probably brings her a lot of satisfaction to know she's probably helping somebody young. The mother is laid up or for different reasons.
Yeah.
Just to move back to the engineering thing, tell us about Cone Tech, because you have a lot of experience with Cone Tech, and I think a lot of our viewers wouldn't understand even that term, CONE and then tech. I know you can go on about this one.
Yeah. So Cone Tech is a large, I think it's one of the major player worldwide in cone penetration testing. So are you familiar with how familiar are with a CPT, a cone penetration test and the equipment? Are you?
Yeah, I'm very familiar with it. I've done it before with Natter.
Right.
And we've had to, I think that there's a company called Alltech, a friend of my son's, and they actually have some relationship with Cone Tech where they'll run the rods, because you can imagine the borehole guy has to handle the rods, right?
Yeah.
And not screw up the data. So they try to find a differentiating edge, these borehole guys.
Right.
And he's done a good job with that. But it's very fine grain. Like if you're not careful, you can damage the cone, right? It's sort of like a inverted hat, right?
Yeah, you're essentially pushing this cone into the ground. It's attached to a series of hollow rods. There's a cable that goes up the middle. The cable at the down hole end, there's a resistance that measures the force on the tip. There's a resistor that measures the friction on the side of the cone. And in between the tip and the cone, there's a porous element that's completely saturated, and it has a hydraulic contact to the water in the soil. So as you push this cone into the ground, these resistors measure the tip resistance, the sleeve friction, and the water pressure. And it's very important to note that it's the dynamic water pressure. It's the water pressure that occurs while you're shearing the soil, while you're moving the cone through the profile. It's very different than a static water level. This was important. And a lot of people get them confused. So anyways, as it's pushed into the ground, these resistances are measured and captured every 20 millimeters or 50 millimeters, however frequently you'd like to capture it at the surface on a computer. So after you've pushed this into the ground to whatever depth you would like, you've got an electronic spreadsheet essentially that has your depth, your tip resistance, your sleeve friction, your dynamic water pressure. And then a lot of the correlations between that tip resistance and the soil engineering properties of soil were done here in Vancouver. A lot of them were. I mean, it's been used in Holland and Europe long ago, but Dr. Campanella out at UBC really moved the in situ testing and testing equipment along quite a ways. So the idea is that if you're in a material, and this is where it really makes these contractors like yourself will get it almost instantly, because in sands, the ratio of end resistance to friction on the side, I mean, it's all end resistance. There's hardly any friction on the side. And if you're in clay, the ratio of tip resistance to side friction is that there's very low tip resistance compared to the side, right? Doesn't that make, it just makes sense. Right. So they kind of ultimately divide it into fine grain materials, clays, silts, or coarse grain materials, sands. It's hard to push it through a gravel. Anything with blows, you know, over say 30, consistent blows over 30, it's difficult to push it in. But yeah, so we've developed all these relationships between the ratio. The first thing that anybody calculates is the ratio of tip resistance to sleeve friction as a percentage. And there's charts that say, hey, if your tip resistance is this, your sleeve friction that, you're in a sand, and the higher the tip resistance is, probably the more dense your sand is. And so you're characterizing, you're giving engineering properties to the soils based on this CPT, this data. Then, you know, the other interesting part is that the dynamic water pressure that gets measured is right behind the tip. So the tip goes in and it measures, say it measures 500 kPa resistance on the end. Well, technically, if you're in a fine grain soil, technically the water pressure at that instant is also 500 kPa, because you're probably in a total, like, without getting too much into soil mechanics, you're in this total stress condition, and the water pressure matches the tip resistance. But the measurement device is right behind the tip. So it drops a little bit when it gets there, depending on the soil properties. And so the measurement that you get there tells you a lot about what your soil's doing. For example, in a really, really soft clay, this is the part that's easy to picture. In a really soft clay, you're shearing the soil, and as you shear it, you're generating water pressures because it's soft and it's completely saturated. And when the particles want to move by each other or move tighter together, there's nowhere for the water to go. So the water pressure really goes up. And then in a really tight soil, like a compact to dense soil, these particles are really quite close together. And for them to slide past each other, they have to move apart, like a sawtooth, they physically have to like go out and around it, right? So that expansion of the soil particles means that what was a volume of 1 square centimeter is now 1.2 square centimeters, and yet it was saturated. So how does it stay saturated when when the soil is actually expanding a little bit? So it sucks water from anywhere around to try and stay saturated as it expands. So the pore pressure really gives you a good idea on how your soil is behaving. Is it dilating, and is it developing negative water pressures as it shears, or is it collapsing, completely saturated in a loose manner that develops positive water pressures, higher water pressures than were there to start with? See what it's really,
it's very interesting.
It's a really good
know
tool.
It well. So you did that for years. I think you started out doing the cones, didn't you? Didn't you start out?
Well, the company I was at had their own cone. They were one of the first company. Well, as a matter of fact, the company I was at, the guy who founded Cone Tech was there. There was 3 of them that started the company, and one of them was David Weller, and they bought a bunch of computers back when nobody else had computers, and they bought a bunch of site characterization tools, including the CPT, which not a lot of firms had. It was still something that was largely being pioneered out at UBC. They had this cone, and they thought, this is great. Like, you know, everybody will want to use the cone, and maybe they'll retain us to use it. And what they found is that nobody would retain another consultant to do their site characterization. So he took the cone and went and started Cone Tech and left consulting. And yeah, that's how Cone Tech came about. And like I said, I think they're pretty big. I think they're worldwide, and they've got offices all over the place.
Yeah, Canadian engineers are well regarded. I think you'd agree that we seem to have a little niche with the variable site conditions in Canada. Like in Toronto, we see a lot of that glacial till where there was a mile of ice apparently on Toronto. But in Vancouver, different, right? You have those deep marine clays, correct?
Yeah, we've got areas that they say that here in North Van at Grouse Mountain, the ice was 3 kilometers thick during the last glaciation. And then, so that was 10,000 years ago. And in the last 10,000 years, the Fraser River has deposited the whole Fraser Valley has been deposited in the last 10,000 years. And it's the Fraser River coming down from almost the Yukon, carrying sands with it and dropping these sands into the ocean and moving out and creating this delta that we're on. They say it's 800 meters thick in places, these sands that have been deposited in the last 10,000 years. So they haven't been glaciated and they haven't been consolidated. And so they can be soft. And then there's areas where peat has grown. There's areas, it's really quite variable here with liquefiable loose sands and peats and rock and till. And yeah.
It's true. I think even that you have an earthquake zone, right? You have earthquake.
Yeah.
Potentially, well, Vancouver could have an earthquake.
They say that we're due for a subduction quake. Are you familiar with this subduction terminology? They've got a pretty good idea of where the plates come in contact with each other, and they say that a main plate out in the ocean is stuck on our plate, and it's building up, and going to give way and have this really quite significant earthquake here in the Lower Mainland. I like to tell a story where as part of grad school, you do this soil testing course, and the idea is that you're going to test these Fraser sands, the sands that are underneath Richmond. They when they get carried down in the Fraser River, they hit the ocean, they just drop. So in order to mimic that in a lab, you take a beaker full of water, and then you have sand and water in another beaker, and you kind of place it. As soon as it's really interesting the way the hydraulics work. As soon as you touch the top beaker on the bottom beaker, the sand starts to trickle out of the top one, all completely saturated as it is in the river, and you see the sand dropping down into place in your beaker. And when you get it up to 8 inches, you carefully take it over and you try and get it in a triaxial equipment and get it to test it. So, I'm carefully making mine. I get it 8 inches and it's smooth as anything at the top. And I tiptoe over to the machine. And when I get it in, I would look, and sure enough, it's dropped a half an inch. Like, I haven't shook this thing. I haven't done anything. Like, 8 inches would drop half an inch. And I would say it took me about 8 tries to get this thing over and not have it any kind of lateral movement that makes it settle. And at the end of it, I was like, wow, like there's no way my acceleration was like 10% of G. Like, you know what I mean? Like, we measure this earthquake accelerations, how the ground moves as a percent of G. And our design earthquake, we think that we're going to have something like 0.3 to 0.4 G here in Vancouver. So 40% of the acceleration of gravity accelerates 9.81 meters per second. So there's no way I was 5% G trying to get this thing in, and it would settle 8 inches, would settle a half an inch. So in Richmond, where the sand is 800 feet thick and it's going to get hit with 0.4 G, the settlement's going to be like, just seems to me the settlement's going to be a big number.
And it's not really designed for that, is it?
Well, it was dropped by the river, right? So yeah, no, there's no design. Now the buildings there are being designed on ground that gets improved and liquefied and densified, but only to a certain depth. You're not going 800 feet. You're going like 50, 60, maybe 30, depending on how much. The idea is that the bigger your building, the bigger your pad of densified material is that you're going to sit on. So lighter buildings don't get as much. They go in and shake it and do ground improvement. You would know, your contractor. I don't have to explain that to you.
What area of Vancouver would you say is where they're trying to do a similar thing as Toronto. There's certain grounds that are pretty firm, and yet they still bathtub them, right?
Yeah, it's
Is that because
I'm
of
not
treatment?
sure, but when you say in comparative area where they're doing what they do in Toronto, I understand in Toronto they've got this issue that Vancouver has identified, and it's been relatively like when you're doing this over 30 years, something comes in 5 years, it's kind of like you're just not sure it's going to stick around, but this is definitely sticking around. And this issue of the cities, it's kind of for me, it's like you said that Toronto has this perched water problem where
Well, I wouldn't say it's a problem. It's just typical characterization that they've overreacted and said we're going to have to dam up the water because we don't want to send the water on a combined storm and sanitary basis to the treatment plant because we get tired of expanding the treatment plants, and everybody basically overregulated. And so everybody said, well, let's go with 3 and 4 foot raft slabs in the bottom of these 1 and 2 acre condo sites, maybe 3 acre condo sites. And obviously a tremendous opportunity to get rid of that, because you'll go down to the bottom and do these raft slabs, and nobody really notices that, hey, there's no water down here. There's no water. So why are we doing a raft slab?
Yeah.
We used to do caissons at the bottom, right?
Yeah. Yeah.
We put a drill rig down there.
Are the soils unsaturated, Martin, from the surface down?
I mean, we have a bedrock that's, like the Sky Dome, for instance, is on rock. If you go Front Street North, all those soils drain, yet they're bathtubbing them all because they think that they said, well, we're going to tax the sanitary. And then you get these large engineering consolidations where the hydrogeologist, this is where Shane comes in, but the hydrogeologist, he says, oh, this is, we're not putting our name on it. We used to do rock at 50 or 75 tons a square foot in Toronto and drill in 3 feet. And now they go 50 tons a square foot and drill in 3 meters and put more rebar in. So I see a lot of opportunity that's based on my experience. We never failed the rock in the 80s.
Yeah. Yeah. Why is it changed? No, if you're telling me that we over design foundations, there's no, absolutely, like those of us in the industry know that.
How do we stop it? Like, how do we stop it, Troy? I mean, that's why I think gray hair, like your experience, and if you care about the CO2 problem we have, there's tremendous low hanging fruit with the systems that I have based on experience. And I obviously patented some of them, but the key is waterproof shotcrete. I think pay attention to that one, because I put Aquagel and E5 colloidal silica. That guy's got patents. Aquagel has patents together with mag oxide, which Sika has, and those 3 together are crackless. So I just put that by the soldier pile, and I save all that money for guys. And for me, I'm trying to save the CO2. I want to have. If I was to say to you, Troy, what's your legacy as an engineer? Like, now you're getting up there, 58, right? Other than being a good father, right? Well, I think your legacy is that you call a spade to some extent. I mean, you just admitted we over-designed footings. I mean, this is the structural engineer's tendency to say to you, well, we don't want a problem, right? That's what they'll say. We don't want a problem, right?
Yeah.
Well, we didn't have a problem in the 80s.
Yeah.
Yeah.
So what I was getting back to about having people here and me not wanting to be on my own is that there's anything I know that's at all useful or valuable was taught to me while I was working as an engineer. And you don't get very much from school. Like, they just don't teach you how to design piles in school or how to design, like, they just don't, right? You're feverishly running from class to class. So everything that gets taught get taught in an office like this. So my mentor was he had a postgraduate degree from Imperial College in London, and it was at that time that he went through. It was like soil mechanics was being pioneered there. Henkel was there, and Bishop was there, and all these names that we read on papers and procedures from the 50s and 60s were there. So when he came to Canada, he'll admit he got a lot of jobs based on his pedigree, but he was stationed in Edmonton, and he said, Troy, the company policy, and by the way, back in the 50s and 60s, there was only a few geotechnical firms in all of Canada, like Leanoff, Golder, Hardy, it dropped off after that. So he was with Hardy, and he said they had a policy that nobody in Western Canada was allowed to give a bearing pressure over 2000 PSF without review from head office in Edmonton. And he was the chief technical reviewer. So if anybody in Western Canada gave a bearing pressure over 2000, like it's just mind-boggling where how conservative it was. And even the the building codes have what presumptive bearing pressures. If your materials are described in this way, you can assume that it's got a bearing pressure of at least that. I read a lot of reports. They don't even use what the BC building code allows them to presume it can be. They use half of that because they don't want a problem. These guys, I don't know what the answer is. I don't think they're getting mentored. I
think we have to educate developers that some guys will save you a lot of money, right? And the developer doesn't want a problem, but the money's to be saved below grade. I mean, buildings are refined, earthquake kind of can get it right by the code, limit stage design, but then down below, and that's where sometimes maybe it's an art to me, but experience matters down below. I see so much waste in Toronto today compared to what it used to be.
But think of it from our side, Martin. Think of it from our side. I go to a developer and say, oh, by the way, this other geotechnical engineer that has the same letters behind his name as I does. And, he speaks slowly and clearly in a calm, unemotional voice. He's giving you bearing pressures that are costing you hundreds of thousands of dollars. How do I say that? I can't just go say that. It sounds disingenuous. It doesn't sound professional. It doesn't. It's a difficult.
Here's an answer to that. Be a proponent of load tests. Like I actually have a new combined modulus pile that I patented, and I put gravel in the pile first. It's a drill open condition, and I put a big HSS in, like a piccolo tube with holes, and I can get 400 ton on it on a production basis, because the gravel at the bottom helps to drain it, but it kind of gets one of the problems we have with drilled shafts is that people think you can't take skin friction together with end bearing, right? But if we tested drilled shafts the way we test micropiles, we get it, right? So it's a bit of a paradigm shift, but I think it's based on load tests. It's hard to argue to say, well, I recommend a load test. That's kind of a way of saying it without saying the guy doesn't know what he's doing. He just didn't recommend a load test, right?
Right.
So, and why did micropiles take off? They're friction piles.
Yeah. Good question.
Yeah. So
I was just talking about we had that conversation on a site the other day. I think it's largely because the drilling guys, I think the cost of drilling dropped and the cost of steel went up. When you drive a pile into the ground, you need, 4 or 5 times more steel just for the driving stresses. You know what I mean? Than you do under static load conditions.
Right, but I think drilled shafts are the way to go, right? Like drilled shafts were always cheaper.
Yeah.
And this has been a great talk. So I think it was easier than you thought. Troy wasn't really that keen on doing this. By the way, the J in front of J Troy, what's the J for?
John. So my dad's name was John, and he named me John. And of course, Mom didn't want 2 Johns in the house. So I became Troy pretty quick. And I don't know why I carry the J in front, how it started, but I just do it now.
A bit of trivia for you. My name's John.
Oh, so you Martin John or John Martin? Well,
it's Martin. My brother's name was Michael. So then my dad's name was John, and John Fraser Halliwell. And then my brother got named Michael before me. I was the youngest of 5. So then my mother liked Martin and Michael. So she called me by my middle name, right? So I'm Martin J, but that J is
John.
Yeah, that's right, John. Anyway, Troy, it's been great having you on the show, and maybe you'll do it again. I just point out that Troy's typically available for an opinion, and we pull them in when we have to, Nader and I. But congratulations on your success, Troy. And, we're definitely going to recommend you and Issue-It, and maybe even GeoPacific for some of these designs. GeoPacific seems to have most of the market share, right? Like, he's done well.
That's the company I was referred to when I got started. I was at GeoPacific right when they were starting out. They started, I think, 88, and I got there in June, or I got there in, I think, September 88. They opened January 1st, 88. And I was there more or less till about 2000, except when I went back to university, or, I was there a long time for the guys that started, Ed Harrington and Jim Madsen were the guys that, and Dave Weller from Contech, but he left pretty quick to start Contech.
And then I guess Matt Kokan was the fellow that had the work ethic enough to take it over at some point, right?
So Matt worked for Contech, worked for Dave at Contech, and for the longest time, Contech operated out of our offices. Like, they were Contech, they had a different address, but it was like a hole in the wall. They would send the data through, and we all, like, it was in the same building and the same floor and the same stairs. And a matter of fact, I like to tell a story. I shared a desk with Peter Robertson, Dr. Peter Robertson, who's now with Greg Drilling and was a professor. So he was doing his PhD with Campi at the time, Campanella out at UBC. And he was going to come to GeoPacific and work, be a consultant with, and he got the job in Alberta and never really put any time there. But I would see him leaving sometimes, and then his cards, they had a box of cards for him that were at my desk. I would see, I'd come in. So yeah, I kind of rubbed shoulders a little bit with Dr. Robertson.
Yeah, very good. Well, for the benefit of any young geotechnical engineers, if I was a young guy starting out again, I'd like to work for a guy like you, Troy.
Well, thank you.
Maybe that'll be your legacy in the end. Is
that would be
what you can do with young people, right?
Yeah, yeah.
Anyway, thanks a lot for being on the show.
Thanks for having me. It was I get nervous about these things, but
you're natural. You have a lot of emotional intelligence, and you'd be a good guy to work for. So,
well, thank you so much.
Okay. Thanks a lot. Take care, bud.
Bye.